In question 5, you're asked to find the coordinates of the stationary points on the curve and determine their nature. A few hints there. Stationary points means differentiate, of course, and we know that stationary points happen at dy by dx equals 0. Nature means are they maximums or minimums. So in the first instance, let's differentiate the function. So we get dy by dx is equal to 3x squared minus 3, following our rules from previous questions. We know at stationary points dy by dx equals 0. It's always good practice to state that fact on your exam. So now 0 is equal to 3x squared minus 3. What I would do here is factorize, so I'll divide through by 3 first of all, probably. So 0 is equal to x squared minus 1, dividing through by 3. Little cheeky one here, difference of two squares, x plus 1, x minus 1, for those of you who remember, and therefore x can take the value of 1 or minus 1. Now it says it wants the coordinates, so some people forget to work out the y value. So when x is 1, subbing back into our original function of the curve, y will be 1 cubed minus 3 lots of 1 minus 2, which is 1 minus 3 minus 2, which is minus 4. So we've got 1 minus 4. When x is minus 1, y will be minus 1 cubed minus 3 lots of minus 1 minus 2. Well, minus 1 cubed is minus 1. Minus 3 times minus 1 is plus 3 minus 2. So that would give me 0. So my other stationary point is at minus 1, 0. Now to prove whether these are what type of stationary points these are, maximums and minimums, what I would do now is add examining points either side. So at x is minus 1, I would look at dy by dx, the gradient, when x is minus 2. I would also look at it when x is 0. And as we can see, dy by dx is 3x squared minus 3. So when x is minus 2, we're going to have 3 lots of minus 2 squared minus 3. Well, minus 2 squared is 4, times 3 is 12, minus 3 is 9. So that's positive. Gradient going that way. Now when x is 0, we can see we're going to have 3 lots of 0 squared minus 3, which gives us minus 3. So dy by dx is negative. That implies that the stationary point, x is minus 1, is in fact a maximum. Now we examine dy by dx, x is 1. Well, we're in a bit of luck here. We know that we could take x is 0, and I would also take x is 2, so point either side. But at x is 0, we already know it's negative, so negative. And at x is 2, we would have 3 lots of 2 squared minus 3, which is 2 squared is 4, times 3 is 12, 2 is 9, so which is positive, going that way. So we can therefore see the nature of the gradient implies that that is now a minimum. Make sure that this is stated clearly and that you don't forget to put in your coordinates.